Here, we're going to go through some of the trickier trig derivatives. There's 10 derivatives on this page, but you really only need to learn 5, and there's a reason why. So if we look at tan, cotangent, secant, and cosecant, we'll notice that the derivatives of tan and secant are secant squared and secant tangent, which, you have to memorize. But then if you look at cotangent, well, it's just the derivative of tangent, except with a negative sign and a co in front of it. So, since if we know the derivative of tangent is secant squared, then that tells us the derivative of cotangent is negative cosecant squared. And the same thing with cosecant. If we remember the derivative of secant is secant times tangent, that helps us remember that the derivative of cosecant is negative cosecant times cotangent. When we get to the inverse trig, arc sine is just the same as sine inverse. Those mean the same thing. We have a similar trick. If you remember the derivatives of arcsine, arctangent, and arcsecant, well, the derivatives of arccosine, arccotangent, and arccosecant are just the negatives of those. So that helps us out. That said, memorizing the derivatives of arcsine, arctangent, and arcsecant is a little easier said than done. I'll start off by saying that the simplest looking one is the one that we care most about, and that's arctangent. So if you have to memorize one of these and only one of these, I'd say arctangent is the way to go. But there is a little bit of a reminder to help you kind of remember which of these go with which, if you're getting these formulas confused. And that will be looking at the domain of these various functions. So the domain of arcsine is the range of sine. And the range of sine is just -1 to 1. That's the only outputs we're going to get from sine. And we'll notice that's also the domain of its derivative, with the exception that we can't plug in -1 or 1 in this case. But we do end up getting the square root of 1 minus x squared. That's domain is -1 to 1, not including the endpoint. The range of tangent is all real numbers, which means that the domain of arctangent is all real numbers. And sure enough, that's also true of its derivative. This has a domain of all real numbers. The range of secant is all numbers greater than or equal to 1 and all numbers less than or equal to -1. And sure enough, the domain of arcsecant is exactly that. And that is also the domain of the derivative, except, of course, with the exceptions at 1 and -1. So I like using the domain to kind of remind me which one goes with which. But all that said, let's go ahead and use these derivatives in some practice. So first we have one which is just adding together a few and subtracting a few of these functions. So let's see what we have here. So first we have the derivative of tangent. We see that as secant squared. Then we have minus the derivative of cotangent. Well, the derivative, so we're going to have minus, the derivative of cotangent is negative cosecant squared. And then we're also going to have minus the derivative of arctangent. And the derivative of arctangent is 1 over 1 plus x squared. So you put that all together, we're going to get a derivative of secant squared x plus cosecant squared x minus 1 over 1 plus x squared. Okay, so we just used those. This problem is here mostly to remind you that the derivatives, or that sine inverse, is the same as arcsine. This is not the same as cosecant, so just remember that. This means the inverse function, not 1 over sine. So what's this derivative going to be? Well, the derivative of arcsine is 1 over square root of 1 minus x squared. And the derivative of arccosine, or cosine inverse, is going to be -1 over square root of 1 minus x squared, which, if you're paying attention, means that when we add these together, we're actually just going to get 0, which tells us something. if we get the derivative of 0, that means this is actually a constant function. And if you don't believe me, go ahead and graph it and you will see that this is a constant function. Okay. As for this third function, I forgot to write derivative there. There we go. For this third one, you might be tempted to think that this is a quotient rule problem if you've heard of the quotient rule before, but it is not. We actually have all the tools we need to do this, and all we need to do first is break up this fraction into 3 parts. First, we have 3/2 cosine of x over sine of x minus sine squared of x over 2 sine of x, plus, I'll cancel the 4 and the 2 over sine of x. What does this equal? Well, 3/2 cosine of x over sine of x is cotangent of x. Sine squared over sine is just going to be sine, so this is minus 1/2 sine of x. And then 1 over sine is cosecant, so this is just plus 2 cosecant of x. Now we're ready to take the derivative, now that we've written it in terms of functions where we know the derivative. That's going to be 3/2 times negative cosecant squared, so that's going to be negative 3/2 cosecant squared of x, minus the derivative of sine is cosine, and the derivative of cosecant is negative cosecant cotangent, so this is going to be minus 2 cosecant of x cotangent of x. So as long as we were able to break up the fraction, we were good. So that's nice. Last, we'll do arctangent plus 1 over x, and we're going to simplify this one a little bit just because I want to. But we'll start with what's the derivative? Well, the derivative of arctangent of x is 1 over 1 plus x squared. And the derivative of 1 over x, remember this is secretly x to the negative 1. So the derivative of that is going to be plus negative x to the negative 2, which we'll write as 1 over 1 plus x squared minus 1 over x squared. And you know what? I feel like simplifying this a little bit. Let's go ahead and multiply both by a common denominator. So I'll multiply this one by x squared over x squared, and this one by 1 plus x squared over 1 plus x squared. So that's going to give me 1 plus x squared over x squared times 1 plus x squared minus, oops, that was wrong, just x squared. X squared over x squared times 1 plus x squared minus, this is going to be 1 plus x squared over x squared, 1 plus x squared. We can go ahead and do a little bit of simplification. That's going to be x squared minus 1 minus x squared over x squared, 1 plus x squared. Those x squareds are going to cancel out, and we're actually just left with negative 1 over x squared, 1 plus x squared, which is kind of interesting. I wouldn't say that's a really straightforward derivative, but it's maybe a little surprising for something as weird as arctangent plus 1 over x, that it just looks like this. So there's some examples using these new derivative rules, and hopefully you can apply those in other problems.